teach you how to calculate moles. If you're a foundation level student, you don't need to learn this. If you're a higher level student, then just let me show you, but can we turn this dramatic music down a bit? Oh, that's much better, thanks. So why do we need moles? The individual masses of atoms and molecules are just too small for us to handle easily, so we look at lots of them together using a quantity called the mole. This actually does make things easier for chemists. So how many atoms or molecules are in just 1 mole of any substance? Well, this is where most students first start to get confused. 1 mole of any substance, whether it's atoms, molecules or ions, contains an Avogadro's number of particles. You can see it's a very large number which you do not need to remember in your exam, it will be given, but it's 6.02 times 10 to the power of 23. So let's summarise so far. So we do need moles in chemistry because it's very difficult to handle the small masses of individual atoms and molecules. So instead we look at lots of particles together. That number of particles is known as an Avogadro's number given to you in the exam, which is 6.02 times 10 to the 23. And that's the number of particles in 1 mole of absolutely any substance, whether it's atoms, molecules or ions. So here are some examples. Magnesium is a metal, and you know that metals are made of ions. So 1 mole of magnesium contains an Avogadro's number of ions. Water is made of molecules with the formula H2O. So again, 1 mole of that substance will contain an Avogadro's number of molecules. But how about if you are asked to calculate how many particles are in 2 moles of a substance? So logically, in 2 moles of any substance, you will have double the number of moles that are in 1 mole of that substance. So the rule is number of particles equals the number of moles times Avogadro's number. Now you do need that rule, but I am not someone who likes to just memorise the rules. It is easier for me if I can derive it as I have just done in this example. Hopefully you will find that useful too. So let's apply that rule to another example, this time 0.25 moles of a substance. You can see that the answer is less than for 1 mole of substance. This is a logical answer because we were looking at 0.25 moles. So here's a level 7 scenario. What if you were asked to calculate the number of moles instead and you were given the number of particles? Well, it doesn't matter which substance or type of particle, does it? So how many moles contains 2.5 times 10 to the 20 atoms? Well, that number of atoms is less than Avogadro's number, so we're expecting the answer to be less than 1 mole. So rearranging the equation that we derived, the number of moles is found by the number of particles divided by Avogadro's number. This gives an answer here of 4.15 times 10 to the minus 4 moles. So we know that 1 mole of any substance contains the same number of particles, but is the mass of any mole of any substance also the same? You can pause the video if you need to think about that. Well, hopefully you know that not all atoms are the same size and therefore not the same mass. So in this example, an Avogadro's number of hydrogen atoms, or 1 mole of hydrogen atoms, will have a mass of just 1 gram, whereas 1 mole of carbon atoms will have a mass of 12 grams. They are 12 times bigger. To be able to calculate the mass of 1 mole of any substance, you need to use relative atomic masses. Now these can be found on the periodic table provided in your exam, or they are sometimes provided within the actual question. In addition, you will also need the formula of the substance. This will tell you how many of each type of atom are contained within it. Here are some examples. So magnesium is a metal, therefore we use its empirical formula, which is just Mg. Looking on the periodic table, its relative atomic mass is 24. This means that the mass of 1 mole of magnesium metal is 24 grams. Oxygen atoms go around in pairs in molecules. So for this formula O2, we need 2 times the relative atomic mass of an oxygen atom. This means that 1 mole of oxygen molecules has a mass of 32 grams. Similarly, H2O contains 2 hydrogens and 1 oxygen, giving the mass of 1 mole of 18 grams. Copper sulfate contains 1 copper, 1 sulfur and 4 oxygens, giving a total mass of 1 mole of 160 grams. So to calculate the mass of any number of moles, we can logically derive this formula again. So if we had 2 moles of a substance, then the mass would be 2 times the mass of 1 mole, or 3 moles would be 3 times the mass of 1 mole. I've introduced here that the mass of 1 mole is known as RFM for relative formula mass, or relative molecular mass is RMM. Essentially here these are the same thing for calculations, but we use relative formula mass for things that contain ions and relative molecular mass for covalently bonded nonmetals. So how would you calculate the number of moles if you were given the mass and the formula of a substance? Pause the video if you need some thinking time. Well done if you managed to rearrange the equation. Pause the video while you calculate the number of moles in these masses of these substances. Please check your answers with the ones shown. I should point out that the values for the relative formula mass or relative molecular mass in brackets should be shown in your exam, as there's quite often an individual mark for completing those. Now for level 9, can you calculate the number of particles from a given mass and formula? Pause the video while you try these questions. I'll give you a clue. It's a 2-stage calculation. So, thinking logically again. If we need the number of particles, we need to know the number of moles. We haven't been given that. Therefore, we need to convert the mass that has been given into moles first. So in this example, to find the number of atoms in 3 grams of neon, we first need to calculate the number of moles, which is the mass of 3 grams, divided by the relative atomic mass of neon, because neon is made of individual atoms. Now we know the number of moles, we can go ahead with step 2 and calculate the number of particles, which is just the number of moles from step 1 multiplied by Avogadro's number. Hopefully you have achieved the following outcomes. If you are still unclear about anything in this list, then have another look at the relevant section of the video. Please click on the subscribe button below for more free GCSE science resources, such as the science quiz shown. You could also visit our website www.science123.co.uk for more A-level and GCSE information.